Hi guys, welcome to the next lesson on relative isotopic mass. In this lesson, we're going to be talking about isotopic masses of elements and their representation on the relative mass scale of carbon-12 and the reason for it. So, atoms, they're made of particles, we know that. But how much of those atoms are in a particle of carbon? Well, it's too difficult to work that out, or too difficult to know exactly the mass of a carbon atom, because the atoms are just too numerous to weigh and count. So to accurately measure the atoms, we've come up with a relative or a standard scale as chemists have created. And this standard mass, to which all atoms' masses are compared against, is the carbon-12. So for example, we have given carbon-12 a mass of 12 units. So the mass of carbon is not in grams, it's not in kilos, it's just units, 12 units. So it's a ratio between carbon and other elements, and it's got no units, so it's dimensionless. The purpose of it, as I said, is because there's too many atoms in the element, and now this gives us information about if we have an atom of carbon, it will equal 12, the mass of it. But if we have an atom which is 1/112th of carbon, it would have a mass of 1. And this is shown here. So individual isotopes, or just forms of elements which have different number of neutrons. So here we've got chlorine 35, and then here we have chlorine 37, and they just have different numbers of neutrons. So here we've got 18 neutrons, and here we have 20 neutrons. These are two isotopes of each other. And they have a relative mass, so that is compared against to carbon's mass. But if we look at other elements here, hydrogen has an atomic number and a mass number of 1 there. It is 1/112th of carbon, therefore mass is 1. Helium is 4/12ths of carbon, so it is 4. Its relative isotopic mass, that particular isotope of helium. So, relative isotopic abundance. So we have a mass of a particular isotope, and that mass will be relative to carbon-12, or in comparison to carbon-12. But each individual isotope will have a particular abundance as well. So there'll be a mass of it in X mass, and there'll also be X percentage or X amount of that particular isotope. So we don't just have two isotopes or one isotope of an element, we can have many, and they'll be in different quantities. So over here we've got chlorine 35, that accounts for about 75% of all chlorine in the atmosphere is chlorine 35, whereas 25% of all chlorine in the atmosphere is chlorine 37, has this relative mass of 37, and the chlorine has a relative mass of 35. So using this information, we can calculate the relative atomic mass of a particular element, and we can therefore use that in our calculations. So to calculate the relative mass of an element, use the average of the isotopic mass, so these two here, these two numbers here, and then you multiply by the percentage abundance, which is here. We'll have a go through a worked example now. So to calculate the relative atomic mass of an element, known as AR, use this formula, the relative isotopic abundance against the percentage abundance, and you add all of the isotopes together and divide that by 100 to give you the relative atomic mass. So if we were to work out the relative atomic mass of chlorine here, we know it has two isotopes. First isotope is 34.969 and the second is 36.966. This one has a 75% abundance and this one has a 24% abundance in the atmosphere. So to calculate the relative mass, simply we multiply the relative isotopic number by its percentage, and we then do that for the second isotope, and if there was a third isotope, we would do that for the third. But there's only two in this case. We then divide that by 100 to convert it into, or to take the percentages out of their percentage form, and we have these numbers here, which gives you an relative atomic mass of 35.45. So when we use the mass of chlorine, that is the mass we are talking about. In this lesson, we've talked about all elements being assigned a mass, and that's based on the relative mass of carbon-12. It has no dimensions, so it's unitless, and it's because there's too many atoms to count. And the relative mass of an atom is based upon its isotopes and the percentage abundance of those elements. In this video, you should be able to now explain what relative atomic mass and relative isotopic mass are, and you'll be able to calculate relative atomic mass and isotopic mass of a given compound. These are the questions to complete for this lesson. Thanks for watching.